Hello there. Let's talk about converting binary to decimal. Just a quick recap for those of you who don't know. Watch my other videos if you're not sure about number bases, but basically, decimal is a number system that has 10 characters to represent a number. So 0, 1, 2, 4, 5, 6, 7, 8, 9. That's 10 characters in decimal. That's what everybody uses. In binary, we just have 2 characters. So it's base 2, whereas decimal is base 10. How can we convert between the two? Well, first, before we can try to convert between the two, we should try to understand what's really going on with normal decimal representations. So if I have a decimal number here, and I say, I don't know, let's just type a couple of random numbers. How do we really know what this value is? How do we feel it? And how do we kind of understand what is the meaning? Okay, so you know that, if you just kind of look at this for a second, you'll realize this is 765,000, right? 765,432. How do we know that this is 700,000? Because it's in a certain position. It's like, several digits to the left. How do we know that the next one represents 65,000? Well, it's one less to the left, so it's 10. It's a tenth of the power of the 7 digit. Same thing for the 5. How do we know that's 1,000? Same thing for the 4 and the 3 and the 2. What we really do is we end up deciding, okay, you know what? The first digit here on the right side, that 2, the strength of that digit, it's got a strength of 1. So 2 times 1 is just 2. So whatever that digit is, if it was a 5, it would just be a 5. 5 times 1 is 5, right? So the strength of the very first digit on the right side is just 1. Every time we move 1 digit to the left, we multiply the strength by 10. The reason we multiply the strength by 10 is because there are 10 possible digits, 10 possible characters that we can use in decimal. Makes sense, right? So that means the 3, we know that represents, an addition of 30 because that's the 10th strength place. Same thing for the 4. We multiply 10 by 10 again to get 100 in that position. So this one has a strength of 100. I'm writing this vertically. Hopefully this is not too messy, but I'm hoping you'll understand. Well, I don't know, maybe if I space this out, does that make it better or worse? Maybe it makes it slightly better. I don't know, I'm gonna roll with it. What can I say? I'm a rebel. Okay. So I live dangerously. The 5, we know that's worth 5,000 because, again, the 4 position over here, that third digit, it had a strength of 100, so we multiply that strength by 10 going to the left to end up with 1,000. So same thing with the 6. I'm not going to explain that any further. It's got a strength of, 10,000. Okay. And then the 7, it's got a strength of 100,000. And it just keeps going and going and going to millions and billions and trillions and however far you actually want to go. So that's how we understand the decimal numbers that we're looking at. How could you imagine this in terms of a formula? Well, we're really raising something to the 10th power. If you think about this, the 1, we could imagine that the value 1 is actually 10 to the 0 power, because anything raised to the 0 power is just a 1. Let me pull up this calculator real fast. I got to stick that on my desktop in the future. If we say 10 to the 0 power, it's just 1. Any number to the 0 power is just 1. Okay, so then we would multiply that strength by the actual digit that we see, the character that we see. So it's a 2. Okay, so that's going to be 2 times 10 to the 0 power. I'm going to put that in parentheses to keep it a little bit clean, or somewhat cleaner. So now when we go 1 to the left to look at that 3 digit, we end up with 3 times something. Let me get a space here for my brain. Times 10 to the something power. Well, every time we go to the left, we just really have to increase the power by 1. It's 10 to the first power, because we're looking for actually just the number 10. So if we say 10 to the first power on that calculator, it's 10. So then, just keep repeating the process. We'll say, all right, the next one is 4 times 10 to the second power. And that should be 100. So if I say 10 to the second power, it's 100. All right. And, we're adding all the positions together, even though we're multiplying the digit by its strength. So I'm going to say 5 times 10 to the third power. And then again, just to double check here, 10 to the third power is 1,000. So you can see the 5 was supposed to be the 1,000th place. And then again, we'll say 6 times 10 to the fourth power. And then just double check here, the fourth power should be 10,000. And then we'll do it one last time. We'll say 7 times 10 to the fifth power, which should be 100,000. All right. So now that we've written this all out, this is kind of madness, right? What you can do now is you can put this into the calculator and it should give you the exact same number that we started with. We should see 765,432, unless there's a typo. 765,432. Nice. Okay, that might have seemed like it was a little bit of a waste of time, but it's not, because now we kind of understand the breakdown of the different positions of the digits in decimal, which means now we can do the same thing in binary, basically the exact same thing, except just use use a 2 to some power rather than a 10 to some power. Because the only reason we use 10 down here is because we were in decimal that has a base of 10. Now let's go into binary, which is a base of 2. So I'm going to just, I guess maybe, what did I do wrong? I hit something and it did a space. I don't even want to know. I don't even want to know. Okay, so let's do a binary number. I'm just going to type a few random digits. I don't know what number this is yet, but let's work it out slowly in the same way. You know what? Maybe instead of doing the formula first and only, let's do both parts like we did with decimal. So what's the position? What's the strength of the position for that first character? Well, I said before, the first character is always just going to be, the first digit's always just going to be a 1, right? That's going to be true in binary as well. So I'm going to say this has a strength of 1. How do we know it's a strength of 1? Because we'll take 2 to the something power. We start at 0 for that first position, and it's going to give us a 1. Okay. So the strength of this one, I already know binary, so I just know off the top of my head that to go to the left, the strength just multiplies by 2, and that's pretty easy after you start memorizing it. I haven't quite memorized hexadecimal yet, but maybe you will in another video. So I'm going to multiply 1 by 2, and I'm going to end up with 2. Double check over here in the calculator. 2 to the first power is 2. So then the strength of this next digit should be 4. 2 times 2 is 4, right? So let's do 2 to the second power. That's 4. Multiply by 2 again. It's going to be 8. Double check over here. 2 to the third power is 8. The next digit is going to be 16 of its strength. So I'm going to write this vertically again. So it's going to be 16. Double check over here with the calculator. 2 to the fourth power is 16. Next digit is going to be 32. Double check with the calculator. 2 to the fifth power. And things are starting to get messy. So I think I'm going to space everything out probably, just to make it easier to read. Tell me if you think this makes it actually easier to read or if I'm making it way harder. I think I'm making it easier. Okay, so we got 32. Next one up is going to be 64. Just multiply it by 2. Double check 2 to the sixth power. That's going to be 64. And then the biggest one that we've written down is going to be 128. Double check it. 6 to the seventh power is 128. We could go on and on and on, but I'm just going to leave it here because I hope we have a pretty good idea of what this means. Let me do some dashes under here, just so that there's some sort of a visual delineation or like a delimiter showing us that these are just representing the strengths and this is the actual number. Okay, so how can we write this out in a formula? Whoa, what did I do wrong? Did you see that? Oh no. Hang on a second. I think I missed it. How many digits are there? If there are 8 digits, then I definitely forgot something. No, okay. There are 9 digits, so the last one should be 256. Okay. So I got it all lined up. At some point, I must have not lined it up. My apologies. But hey, maybe I'm making these mistakes on purpose to make sure that you're paying attention. You never know. I want you to think. So 256 is going to be the next number. Double check it with the calculator. 2 to the 8th power, 256, cool. By the way, a quick trick in binary that you can always remember is that the number, the actual highest number that you can represent in an unsigned binary integer is basically the strength of the highest digit, you know, this 256 here, multiplied by 2 and then subtract 1 from it. So 256 multiplied by 2 is going to be 512, so it's going to be 511. So I could represent a number between 0 and 511, or 512 possible combinations. Okay, so now let's work out the formula. See, 16, 36, 64. Okay, I did it okay. I probably should have rehearsed this. So let's do each position. So it's either always going to be 1 times something or 0 times something, right? Because binary, these characters can only be 1 or a 0. So let's do, starting from the right, we'll say 1 times 2 to the something power. It's going to be 2 to the 0 power because that's, just going to be a 1. Working our way over to the left, it's going to be 1 times 2 to the something power, 2 to the first power because it just increases every time. The power increases. We have 4 ones in a row here. I got to try to remember that. This is where I'm going to start making lots and lots of typos. 2 to the second power, and then we have another 1, 1, 2, 3, 4, or 1 times 2 to the third power, and then again we are going to hit a 0, so it's going to be 0 times 2 to the something power. You might be tempted to omit the zeros. You can if you want to, but for me personally, it helps me quickly visually see that I'm getting the powers in the right order. I can see 2 to the 0 power, first power, second power, third power, fourth power. Sometimes when I omit the zeros, I end up kind of like messing up the order of the powers or the order of the exponents, and I have to redo everything all over again. So I just keep it this way. Okay, so it's 1, 1, 1, 1, 1, 1, 1, 1, 0. So there's another 0 that we need, times 2 to the 5th power. So we got both of those zeros now. And then we need another 1 times 2 to the 6th power. And then we need 0 times 2 to the 7th power. Okay, and then we have another 1 times 2 to the 8th power. And I know we're supposed to be done on 8 because that's what we were doing before, the 256 strength. So unless I made some mistakes here, this is probably the number that we can punch up into the calculator to see what this binary number is. So I'm going to punch it up. Huge. It says that it's the number 335. Let's see if that's actually right. I'm going to punch this up in my personal calculator real fast. I'm going to say 101.01111, and the expression is decimal 335. Yep. So that's it. We know how to convert we know how to convert from binary to decimal. And just again, like as a quick shorthand, it's probably a good idea if you're involved in computer science, if you try your best to memorize these positions up to maybe 65536. That might sound a little extreme sometimes, but I don't know. Personally, I'm not like the most advanced binary reader at all times, but I can remember up to that much. And what do I mean when I'm saying that? I'm saying, start with a 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192, 16384. Took me a while to remember that one. 32768, 65536. So if you think about it, how many bits is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right here, 16. That'll give you 2 bytes worth of memorization or a word on many systems. For me personally, I like to go up to 65535 because remember I was saying, what is the highest number that you can go up to with a certain number of bits? It's always the power or the strength of the highest bit multiplied by 2 and then subtract 1. So when I remember 65536, that tells me that if I have 2 bytes, I can represent a number between 0 and 65535. This is very, very useful if you're going to be working with binary numbers a lot, or if you're taking exams or whatever it is that you're doing. I would recommend everyone do this. Okay, what do you say? What do you say we do another binary number, but we'll just do something a little bit smaller to make it easy. Okay, so by the way, when you start to memorize these positions, you can start to eyeball it, which is really, really fast and a good idea. Like I can see those two numbers right there. I know the first one is a 1 and the second one is a 2. So that means the 1 and the 1 are just going to be a value of 3. Then I just quickly go, all right, 1, 2, 4, 8, 1, 2, 4, 8, 16. So it's going to be 16 plus 3. So it's going to be 19. I guarantee it. Let's double check this real fast. We'll say 1 times 2 to the 0 power. And then we'll say 1 times 2 to the first power. And then we'll say 0 times 2 to the second power. And then we'll say 0 times 2 to the third power. And then we'll say 1 times 2 to the fourth power. And if I didn't go too fast and make a bunch of typos, it should be the number 19. So there is a lot of benefit in memorizing the strength of these different positions. I personally never remember very much beyond 256 when I'm actually like trying to, work out a number conversion. But when I'm just thinking of like how to compute things, it's faster if I can go up to 65536. Okay. I hope you enjoyed this video. I hope you learned a little bit of stuff. I hope you had a little bit of fun. I'll see you in the next one. Hey everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. Sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? Just send me a comment. Whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.